Hello guys, this is Paul McWhorter with TopTechBoy.com, and we're here today with episode number 34 in our incredible new tutorial series where you're teaching your Raspberry Pi who's boss. What I'm going to need you to do is pour yourself a nice tall glass of ice cold coffee. That would be straight up black coffee poured over ice, no sugar, no sweeteners, none needed. And as you're pouring your coffee, as always, I want to give a shout out to our friends over at Sunfounder. Sunfounder is actually sponsoring this most excellent series of video lessons. And in the class, we're using the Sunfounder Raphael Raspberry Pi Kit. The Sunfounder Raphael Raspberry Pi Kit. Now, most of you guys probably already have your gear, but if you don't, look down in the description. There is a link over to Amazon where you can pick this kit up. And believe me, your life and my life are going to be a lot easier if we are working on identical hardware. But enough of this shameless self-promotion. Let's talk about what I am going to teach you today. And the kind of direction that we're moving in this class now is to start moving towards the ability to make standalone projects that you could take away, you could sort of detether from your computer screens and your keyboards and all of that and deploy them in an actual use environment. And so if you think of kind of like where we are now, the Raspberry Pi has cables coming out to go to the monitors. It has cables coming out to go to the keyboard, the mouse, and then having power come in. And so we're able to demonstrate some pretty cool stuff on the desktop, but we're pretty far away from being able to have something that is self-contained that could work in a real application. That's the direction that we're going. Now, we've made some little steps in that direction in that earlier on in this class, we learned how to use an LCD display with the Raspberry Pi. And then in the last couple of lessons, we learned how to use the 16-button keypad with the Raspberry Pi. So what we're going to do today is we're going to take the next little step in moving towards a portable or a deployable project by making the keypad and the keypad and the LCD work together, where you can get a prompt from the LCD and then you can respond to that prompt using the keypad. And so that's what I'm going to show you today. Then I'll give you a homework for next week, and then we're going to kind of step by step be trying to detether ourselves from the desktop. Does that sound good? I hope it sounds good. And let's see, I need to move over here, and we're going to try to get over to the sketch pad. And while we're waiting on that, I'll kind of show you how I have things hooked up here. And in the past, we've used the LCD display, so you're already familiar with that. And in the past, we've used the keypad here, and you are already familiar with that. And so now what we are doing is we are combining those two. And let's see, I think you'll be able to see that all right, I do believe. So first of all, let me jump in and just remind you how I have this thing set up. Now, when you have the keypad with the buttons up, you remember that these wires coming out are row 0, 1, 2, 3, and then column 0, 1, 2, 3. So it's rows across and then columns. So rows 0 through 3, columns through 0 through 3 as you go across there. Then the way that we have that hooked up is we come over here to the pin out, and we're using those inside pins. We're using those inside pins on the Raspberry Pi. And so you can see that we're going to just sort of come down the line, and we're going to connect to 11, 13, 15. And then we're going to jump down and connect to 29, 31, 33, 35, and 37. And that way we can get all 8 of those pins coming out of the keypad hooked up. So let me just sketch that out for you real quick here. So let me just show you real quickly how we have that hooked up. It's the same as last week, but in case you missed last week's lesson, we have the keypad. Coming off the keypad, we have 8 leads. 1, 2, 3, 4, 5, 6, 7, 8. This one is R0, R1, R2, R3, C1, C2, or C0, C1, C2, and C3. And then those are hooked to 11, pin 11. And again, this is physical pin 11. So it starts up here at physical pin 11. We're going to go 11, 13, 15, and then jump down to 29. So it's going to be 11, 13, 15. Then we jump down to 29. And then we have 31, 33, 35, and 37. So we just kind of come right down that inside column, using the GPIO pins. All right, hopefully that makes sense. Now we also need to hook up the LCD. And the LCD, if you look on the back, if you look upside down, it's really very straightforward to hook that up. And so here I'm drawing it as if the LCD is upside down, and what you will see is 4 lines coming off. And the good news is on the board, these lines are marked, and what they're marked is G and D. They are marked VCC, and then SDA and SCL. And then where we hook those two on the Raspberry Pi, so here's the Raspberry Pi, where we hook those two is, of course, ground, G and D, and then the VCC, we need 5 volts, and then the SDA is physical pin 3, and the SCL is physical pin 5. So let's come back over here and look at this. I got the 5 volts up here at the upper right, you can see it, and then I use the ground right, which is pin 6, and then you can see over here physical pins in purple, physical pins 3 and 5 are SDA and SCL for the Raspberry Pi. Okay, hopefully that makes sense. Now what you just need to do is you need to go ahead and get that hooked up, because it should just take you about 2 minutes, and I'll get this stuff out of the way and I'll get back over here and see if we can get ready to start coding. Now, a couple of things before we start coding, you're going to need those libraries. And if you haven't been taking this class along the way, you need to know that there's 2 libraries you need. You need the library for the LCD1602. And if you come to the most excellent www.toptechboy.com and you use this happy little search icon here, you can search on something like library for I2C connection of the LCD1602 to the Raspberry Pi, and then you'll come up with this library. You will need to take this, you will need to copy this, and you will need to paste it into a Python program, and then you will need to save that as LCD1602.py, and you need to save it in your main Python folder, the folder that has the programs, your Python programs that you're running. And so the program you write, if you put it in a certain program, if you put it in a certain folder, then this you need to put in that same folder. But this is going to be your LCD library, and we talked about that back a few lessons ago. And then you're also going to need the library that we developed last week, and that you can find at www.toptechboy.com. If you search on something like library for reading a 16-button keypad, you'll come down here, you'll see this code, and this code you need to save in your Python folder as uppercase KPLIB.py. Okay, so now when you have those 2 in your main Python folder, then you are ready to come over here and begin to code. So let's see if I can get set up here. All right, so now this is what you'll see better up here that we're trying to do. So what we're trying to do is we're trying to get rid of the keyboard from the Raspberry Pi, and we're trying to get rid of the screen. And so if we get rid of the keyboard, you've got to be able to input information somehow. So we're going to do that with the keypad, and then you have to display prompts or display values or display information to the user, and we're going to do that with the LCD. And I'm just going to sort of show you a real simple demo today of prompting from the LCD and then reading from the keypad. And so I think let's just see if we can jump in, and let's see if we can get busy with that. Let me do a little bit of Windows management here. All right, so I'll come back over here, and let's see, you need to see my code view. All right, so you can see my code view, and I think we are ready to program. Okay, so the goal is to prompt the user on the LCD and then get the input from the keypad. So how are we going to do that? Well, we're going to start with import, and we're going to import rp_i.gpio as GPIO, so you guys are familiar with that. We're going to import our LCD library, and that was LCD1602. You should have put that in your folder already. And now we are going to, from KPLIB, we are going to import keypad. Now, just to make sure that you understand this, when you save the programs, when you save the libraries, you save them with the .py. You save the libraries with the .py. All right? But when you read the library in, you read it with the file name and no .py. No .py. So from KPLIB, we're going to import the keypad. Now we've got the libraries to interact with the keypad. We've got the libraries to interact with the LCD. Now we're also going to need some delays in here, so we're going to say from time import sleep. Now we need to initiate our keypad, so I'm going to say my keypad, and you should understand this if you watched last week's lesson. That is going to be we're going to create an object. We're going to create an object, my keypad, and that's going to be equal to keypad, which is a method up here, right? This is that keypad method that we imported, keypad. And then what it needs is it needs the parameter of what is going to be the return key. So when we interact with the keypad, you're going to type in numbers, but then you need to tell it what is the return key. And I want the return key to be this D. So I'm going to set the return key to be D. And I think that's what we did last week. And so I need to tell it what the ret char for return character is going to be equal to the uppercase D character. So if it sees D, it knows that you're wanting to enter the data. Now we're also going to need to turn the LCD on. So I'm going to do LCD1602. That's the library that we just imported. And then I'm going to init that. And then I need to tell it 0x27 and then comma 1. All right, guys, this is using I2C, and in the earlier video, I think it was like lesson number 7, I showed you how to set up the LCD I2C. If you set up I2C, this will work. If you haven't set up I2C on your Raspberry Pi, you need to go back and watch that video, and that way it will come on. But I don't want to go through all that again today because this is a class, and if you've taken the earlier lessons, you've already done it. But if you haven't, you can go back and watch that one video. Okay, now we're going to do a try and accept, and so I will try. And whenever I try, I always like to go ahead and do the accept so I don't forget it. Let's see. Okay, so I will do an accept, and the accept will be on keyboard interrupt like that. Okay, and then what am I going to do? I am going to do a sleep for about 0.2 to let things finish up, whatever's happening. Then I am going to clear the LCD.clear, so I leave the LCD screen clean, and then I'm going to do a GPIO .clean up to release those pins like that. Okay, now inside the while loop, what I want to do is I want to prompt the user for an input, And then what I want to do is I want to then give that value to the LCD. And so let's see how we'll do that. Well, first of all, I'm going to prompt them. So I'm going to say LCD1602.write. And I want to start in the upper left, so I'll say 0, 0 for column 0, row 0, and then I'm going to tell them to input value, like that, okay? And then I'll put a colon, I'll close that, I'll close the, the write. So that's going to go to the LCD. Now what I'm going to do is I'm going to say my string is equal to my pad, that's the keypad dot read keypad, that's the method, and then I'm going to read it. So it's going to go out, and then you're going to put a number in, and then when you click D, when you press D for enter, it's going to return that value. Okay, it's going to return that value. And where is it going to return it to? It is going to return it to the string my string. And so now you have that value that you got from the user. Now what I'm going to do is I'm going to say LCD1602.write. And again, where am I going to write? On 0, 0. And then 0, 0, and then what I am going to do is I'm going to say user input was. Hopefully that'll fit on one line. If it doesn't fit on one line, we'll have to come back and make that shorter. You become the master of abbreviation as you're doing that. And then we're going to do LCD1602.write. Okay, and this time we're going to write on column 0, row 1, which is the second row. And then I'm going to put my string there. So what are we doing? We are prompting the user for input. We're then getting the input, and then we're displaying the input. And those are the types of things that you would want to do in a system like this. It's just kind of a skeleton, but it's showing you how to bring these things together. Okay, now also we're probably going to want to do this in a while loop because we wouldn't want to just run this program one time. So we'll say while true. When is true, true? True is always true, so this will be an infinite loop. And then we're going to come down here and we're going to put all this inside of the while loop. And then we're going to come over here, and then I think what we'll do is a sleep for 5 seconds, and then after sleeping we'll do a LCD1602 .clear, like that. And so what's going to happen is it's going to ask you for input. You're going to give it the input. It's going to display the input back to you, and then it's going to clear the LCD and then go around again. And it will keep doing this until what? Until you hit the Control C, and then it will jump down and clean things up. Could it really be this easy? Could it really be this easy? Okay, so I think I need to switch over here to this view, and you can see a live view of the LCD, and you can see a live view of the keypad. And let's just see how this thing works now. So we will come up here, we will run the program, and indentation. What is that nonsense? Man, this whole thing was indented crazy. Can you believe that? How did that happen? Did you see that? Let me show you what happened over here. It'll take about 30 seconds to fix it, but everything was indented over, and I don't know how I could have possibly done that. Okay, and then these need to come into. Okay, so I think that should have fixed it. Hopefully it wasn't indented more than, ooh, it was. So somehow I ended up crazy in the middle here. We'll get this taken care of. Never fear. Okay, so hopefully that will work. Let's come back over here to the overhead view. And now I'm going to come in and I am going to try to run this thing, and then keep your eyes on the LCD as we run this. So let's run it, and syntax error. Oh, LCD02.write. That is not, you don't want to, let me show you. I hope you guys were screaming at me, but I put a period there where, of course, that was a silly thing to do. So now let's come back over to this view, and now we are going to run it. And okay, didn't put the didn't close, or I opened my string. My string is a variable, so I should not have had that quote in there. I got a little sloppy here, a little bit sloppy. So let's run it. My pad is not defined. Oh, I see what I did. Okay, so you see, that was in line 11. I said my string is my keypad, is my pad, to where I name my object my keypad. So I need to name my object the same thing that I'm going to be reading from. Man, I hope you guys were yelling at me. Okay, so let's run this thing again. Okay, so that time we just got the error that we hadn't cleared out. We hadn't cleared out the GPIO pin, so that should be okay. I'll kill it. I will come back over here to the overhead view, and we are going to run, and boom, look at that. So what do we have here? We have input value. Okay, well, I want the value 1214. Okay, nothing happened. Why? I didn't click enter. What did we tell the keypad that the enter key would be? The enter key would be D. And so then I press D, and shazam, look at that. User input was 1.1214. Now it says input value. Let's go A2356, A2356, and enter. And it has the input A2356. Boom. Okay, so guys, this has taken 2 or 3 lessons to get to this point, but where are we now? We're at the point that we could take the keyboard away, and we could take the monitor away, and we could have this thing sitting there, and it could be asking us for values, and then we could be putting values in, and then it could go out and do things based on the values that we put in, without having to have it hooked up to the keyboard and without having to have it hooked up to the monitor. But now I want you to look at this, and the way we wrote this, though, let's think of kind of like a direction that I'm thinking about going with this is, what if we built a little alarm system with the PIR, with the little PIR motion sensor? And what are some things that we would want to do? What are some things that we would want to do on the keypad? Well, we would want to arm it, okay? We would want to disarm it, and then we would want to change the password, say. All right, but look, when I ask for input, what does it do? Okay, it asks for the input, and then it gets the input, and then it shows me the input, and then it sleeps for 5. Now, what's going to happen in a real-world scenario? Well, in the real-world scenario, you're going to be wanting to go between arm and disarm, or between disarm and change password. You're going to be wanting to go between those. And you can't just come in and put a sleep 5, okay? Because while you're sleeping 5 and while you're reading from the keypad, you were supposed to be what? You were supposed to be armed, okay? And so you can't, you know that in that arm part of the program where you're reading to see if there's an intruder, you cannot be reading, seeing if there's an intruder, and at the same time waiting to see if the user wants to change modes. Because if I want to get input from the user, I have to ask for it, and I have to sit there and wait for it. Okay, and I don't know, the guy might want to change arm to disarm 1 time a day or 5 times a day, so I can't just sit and wait for him to change states, change modes. Why? Because while I'm sitting and waiting, I'm not looking for an intruder. And so this gets into the problem of sort of computationally, you operate one line of code at a time. And if I'm sitting here sleeping 5, everything else comes to a stop. Or if I'm sitting waiting for the user to input what mode he wants to be in, I'm not monitoring. Does it make sense what I'm saying? This is a blocking type of thing. Waiting for user input blocks everything else. So for us to make progress, what we've got to do, if we're going to do something like an alarm system, for us to make progress, we've got to do it in a better way. And somebody tell me the word. What is it that we want to do? It's something that I taught you in the Python lessons. I don't think we've done it in the Raspberry Pi lessons yet. But what is it that we want to use? We want to use threads. Okay, we need to have a thread, and we need to have a thread that sits and constantly reads input. It constantly is watching the keypad, and then if there's any input, then it passes that to the main program. So the main program is sitting and looking for an intruder, or the main program is sitting and is disarmed. Okay, but as it is sitting and looking for an intruder or sitting disarmed at the same time, up here, there's going to be a thread that is running. And what that thread is going to do is it's going to be constantly looking for new input from the user. Okay, so that is going to be the homework for next week. And what I need you to do is I need you to write a program. Now, if you guys didn't take the other lesson, if you guys didn't take the other Python class, then maybe you don't know how to do threads yet, but you can try to be aggressive and learn how to do threading and incorporate threading into this, or you can wait and just watch my solution next week. You guys that are doing threading, you'll see this is the perfect opportunity to use threading. So here is the homework assignment. I want you to be thinking in terms of we're moving towards a little standalone alarm system with a PIR sensor. We're not adding the PIR sensor at this point. We're just trying to get our program flow going. And there's going to be 3 different states that this can be in. State 1 is it's armed. While it's armed, it's sitting there looking for an intruder. State 2 is going to be disarmed. While it's disarmed, it's sitting there and it's not going to set the alarm off because it might be you walking around the house. You come home, you disarm it. You don't want it going off while you're walking. You don't want the alarm going off while you're walking around. And then the third thing is to change the password. So it's kind of like A could be for arm, B could be for disarm, and C could be for change the password. Okay, now also what you got to think is you've got to incorporate that password into your program flow. So if I just come in and click disarm, that's no good because I might be the intruder. So disarm needs to come with the password. Or when you arm it, you need to put in the password. So to change states, you need to put in the password. So you need to put in, if you want to arm it, you need to have to put in the right password in order to arm it. Or if you want to disarm it, you need to put in the right password to disarm it. And then option C is going to be to change the password. And of course, to change the password, you need to put the old password in. And so guys, I did this in not too many lines of code, so it's not that hard if you think through it and don't make it too complicated. But that's going to be your homework for next week, is to get that program flow going. And then in the week after that, what we're going to do is we're going to probably add in the PIR sensor and an alarm. And then the week after that, we'll try to figure out how to go even more mobile with the thing. So this is going to be another 3 or 4 lessons on this, but it's really showing you, even though kind of what we're doing is the example is an alarm system, the skills we're building you would use for any type of portable device. Does that make sense? I hope it does. Guys, I hope you're having as much fun taking these lessons as I am making them. If you enjoyed the lesson, give us a thumbs up. Leave a comment down below because that helps us with the old YouTube juice. And share this video with other people because the world needs more people building things and doing engineering and fewer people sitting around watching silly cat videos. Paul McWhirter with TopTechBoy.com. I will talk to you guys later.